Okay, I've got to find the right hex. I call them hex. Allen wrench. Okay. I'm going to mount these on here. Now, just for info, maybe I'm overcautious, but I put a little bit of oil on the screws because this is a long way to go self-tapping. I did not have the proper tap. So this is threading through the acrylic, and I'm going very, very slowly and doing just a couple turns per screw because the screw gets hot, and as the screw gets hot it's going to expand, causing it to be harder to turn, and you'll hear the sound change as it wrenches in there and it starts getting hot on you. You let it cool down and it turns easier. You can hear that turning, and that one is tightening up almost. That's really tight. Okay, it was getting hot. Just a little bit at a time. Let it cool down in between. This is just me. Some people might just wrench it right on in there, but I'm careful, maybe overcautious. Once it starts to make that little bit louder noise, you'll hear it in a minute. There. Then I stop, let it cool down a minute, go on to another one. I'm just want to do it nice and gentle. But a little bit of oil helps. Okay. Helps that slide in better, because you are basically tapping that in through sheer force. And I just don't want to break anything. That one's going to take a little bit longer, but I've got the top two done. So I've got my electronics plate on, and it's very strongly mounted. So anyway, I'm going to finish that last screw, and then I can start wiring my rectifiers. Hey everybody, I am putting the wires on the bridge rectifiers. I do not have express permission to show the wiring diagrams, so I am going to be just showing you some tricks about wiring that I know. I'm dealing with 18 gauge, I think it was, wire, and 12 gauge connections, crimp-on connectors. So what I do, let me see if I can see my camera here. What I do is I take and I fold over the end of the wire a little bit, see? So that it fits when I press down the crimp-on connector. Now, I have to connect two together here. Alright, and what I'm going to do is hold them together closely, slide them into the end connector side by side, make sure they go in there nice and neat and tight, and then double check that they're both in there together. I don't know if you can see that, probably not. And then I use my Leatherman because it has a tougher crimp connection, I believe, than the actual crimping pliers. I get a better grip with the Leatherman than I ever did with the pliers. And then I squeeze, and then I press it between my legs with my entire strength. Maybe I can show you, yeah. And I press really hard. The Leatherman can take it, right? And then I have a really good, solid, stable connection. Now, if you can wiggle the wires and you feel any motion in there, you have a bad connection. Redo it. Another thing I like about the Leatherman is I can position this in here on the edge and get a better crimp, alright, if I need to. Not that I need it on this one, but I just want to demonstrate how that works, okay? Now, I'm forming jumpers. I'm not going to show you all the circuits and how this all goes, but right now what I'm doing is forming jumpers to connect all these together. And okay, so when you got a single wire you put in there, and then I don't crimp it yet, I line it up in there tight, make sure it's straight, and then I crimp it, and then press hard. And I get a much better connection this way, I believe. I prefer using the Leatherman myself. I've always had better luck with the Leatherman. Now, this is going to be a 3-way connection here in the middle. This is going to be fun. I'm going to be putting 3 wires in at one time in the middle. In the previous one I goofed and I forgot to put one of the wires, so I ended up with, I'll show you in a few minutes, maybe I can't get all 3 in there because of the lip I made. I'll have to tighten the lips on them. My previous, on the plus, the positive sides, I goofed and forgot to double or triple up on the one. So I didn't make a 3-way. Let's see if I can pull this off, if they'll fit in there. I'm not sure if all 3 will go in there. Make sure that all 3 are in there. You got to make sure all 3 connections are going to be made solidly. Because if it's not, then it's all for nothing. Alright, I don't know if you saw what I was doing there, but then crimp it on with the Leatherman for a better grip. No. Oh, there's a little bit of wobbliness in the one. I probably didn't get him through all the way, so I'm going to crimp it again with the edge of the Leatherman crimper, which is why I like the Leatherman. I get a more controlled crimp. Yeah, I'm not liking the feel of that 3-way. Okay, now this one goes over here. So all I'm doing is connecting the outputs, all positives together and all negatives together. That's all this is. Nothing special, nothing weird. So there's nothing secret here. But when I wire up the coils, I'm going to keep that quiet for the sake of the company. I don't know if they want those details shared with the public, so I'm going to respect that and not show you when I do the coils. That's why I'm showing you this. This is no big deal. Okay, I can see them very well. 2 at a time goes very, very well. Make sure there's no wobbliness. If there is, hit it again using the edge of the crimper. You want a very good connection. Alright, there's that. Now I've got a adapter here. It's like a Y adapter, okay? And what I'm doing is I'm putting them on here. Where's my final output? I hope that isn't going to give me any trouble. I'm going to have to put that, let me see, because I got my AC wires. All my AC wires are going to be jumpered with a double. It's going to be tight, but I think I might, oh no, that's going to be too tight. I can't do it like that. So, with the positive wire, I have room to jumper out with this, but with the negative, it's going to touch the AC wire. So I've got a bit of a problem here to get that. Anyway, I've got to figure that out, and then I'm going to put all this in place, and then I'll have my output coming off of there. So anyway, I'm going to take care of that. I'll get back to you when I have everything done. It's going to take me a while. So I'll work on this, and then I'll still have to do the timing, and then this here, and then we should be able to be running today. So we'll see how it goes. Hey everybody, much time has passed, and I have all of the coils wired, all the plus wires, positive lines wired, and all of the negative lines wired. I still have to connect the motor run wires and the timing circuitry and a solid state relay. So, wow, quite a job. Alright guys, just real quick, I gotta go get Melanie. I have finished the machine. Let me get better light, hold on. Alright, I finished all the wiring, and I've got a battery hooked up that is 3.96 volts, 9.5 and dropping, 0.39. Actually, it looks like it's draining. When I hooked it up, it was 0.5, I think, when it's draining. It's odd. I wonder if the voltmeter is draining it. Well, this is a very, very bad battery. Now, without hooking up power to this thing, just the coils, just the magnet spinning past the coils and going through the rectifier diodes. No power connected, alright? Just manually spinning this by hand. I'm actually putting a charge into this battery and increasing the battery voltage. It's hard to maintain, but I am putting a voltage into this. So it is definitely working. Well, there's 0.4 and dropping again. So at least I have a generator, at the very least. Look at this, guys. I've only got one coil pulsing. I can't believe it's turning this slow. I can't believe it's actually turning. I've only got one coil hooked up because I was troubleshooting. I had a wire hooked backwards on the solid state relay, but I finally figured it out. It was my bad, but it's, look at this. I can't believe it's actually turning. Now I've got a little tiny 6-volt battery here, and I've got a dead 12-volt battery here. I've got to hook up all the power wires again. I just think it's amazing the thing's actually turning, that it's actually not stopping with only one coil pulsing. Now I could probably speed it up, but I'm just like smiling hugely right now. Anyway, I'll give it a faster spin, and I gotta make sure which way it's supposed to be working anyway as well. I'm not sure which way it's supposed to spin. I can't remember. It was in the instructions somewhere, clockwise or counterclockwise. I've got to look. And then I've got the timing to play with and adjust, and oh boy, there's a lot you can do with this thing. But right now, look at that, Melanie, it's still going. Really, really slow. I can't believe it. It's just cool watching it go this slow after all this work. Alright guys, I'm gonna get it put back together properly. Well everybody, I have a running motor. It took me a long time, a few hours, to play with the timing. 3 hours to be exact. It took me 3.5 hours, 3.5 hours to play with the timing. But that's to be expected with such a thing, trying to fine tune it and get it running. In the end, what I did is I held the reed switch in my hand and moved it around until I got the motor to run. And by the way, it is a self-starting motor, which surprises me. It is totally self-starting. I don't know if that's how it's supposed to be, but mine is a self-starting motor. It just does. I don't remember in the videos them being a self-starter, but for some reason this one is starting itself. Don't know if it's good or bad, but it is what it is. It's running off a 6-volt battery, so it's running pretty slow. This is a little 6-volt battery, and I've got here a dead 12-volt battery that was at 0.5 volts. I should have checked it on camera, but right now it's low enough. Let me hook up the meter and I'll show you what it's at now. Alright, it's hanging around 5 volts now. So now if I disconnect the power to the motor, okay, You can hear it stop running. That's going to drop on down because it is a very, very dead battery. Motor is spinning quietly. Absolutely silent now. That of course is going to settle after a while. This is down to about 6.13 volts. So that's, it was at 6.26, but I've been running this for a good hour. Well, actually with the timing and everything, well over an hour. So if I hold it on there, it should self-start. Oh, now it's going to prove me wrong today. Alright, well, I gotta put the camera down. I'm going to hook that up. Hold on a minute. Okay, maybe it's not a self-runner now. While I was fine-tuning it and trying to get the timing, it would start running on its own, but I guess that's because I was moving the relay, and it would draw a magnet in and cause it to, well, when I moved the relay and it sent power to the coils, it would draw the magnets, and I guess I was causing it to start then. It looks to me like right now it's not going to be a self-runner. If I slow it on down and then put the power on, I guess it depends on where the coils are. Yeah, see, I think it depends on where the coil is in the rotation. It may or may not self-start. So I want to try to give you the big picture here. See, it self-started. But it depends on where the coils are. Well, the magnets are in relation to the coils. Alright. Yeah, I mean, yeah. It's working for me. And the voltage is going up. Shut that right on down. Now, as long as that's spinning, the battery voltage is going to be increasing, because this is a generator now. It is going to generate electricity just because there's magnets passing coils. So it is going to generate electricity, regardless. See, it's dropping down. Now I'm going to spin that by hand with no power on. Watch this, okay? Give it a spin. And of course the voltage here, I'm going to give it a better spin by hand here. It's awkward to hold the camera and spin this. Okay. I'm spinning it by hand. And the voltage is going to go up without any power applied. Alright. So it is going to be a generator just on the simple fact that there's magnets passing coils, and it's pretty decent magnets and pretty decent coils. There are 12 coils here and 6 extremely high power magnets, and then a bridge rectifier set, one for each pair of coils. So it is going to produce power. You just spin that, it is going to produce power, just because of the simple fact that I'm spinning it. Okay. So, hook it up again. I'm just going to start kicking out the power. Now, I'm only putting 6 volts in, and so I don't expect any high power out. It'll be very interesting to see what happens when I get a 12 volt battery out here. I don't know what will happen if I use a lithium battery with this device though, so I'm really reluctant to try a 12 volt lithium. Really reluctant, because there are high voltage spikes, and there may or may not be spikes coming back into here. And until I get an oscilloscope on here, I won't know for sure what's going on. I just hooked up an old battery jump starter just for kicks, using the same 6 volt battery. Now I'm getting 18 point something volts. Odd. That was flat dead. It was 1.5 volts when before I started the motor. I should have showed it. And it's showing 18 volts. Well, I could stop this. Stop the motor from spinning. So it's a really dead battery. Really dead battery. I'm surprised the voltage goes that high. So I guess I'm not restricted by using a little 6 volt battery. And that should tell you there's something going on here other than a 6 volt battery is not going to give you 18 volts out. So there's something interesting going on. I'm going to reconnect this. It's I can't do it with one hand. Maybe with, hold on. Maybe There. Did it. Oh, it's running slower. Odd. I wonder if my timing needs to be changed. Oh, there it goes. Oh, it's running faster this time. Interesting. It's running faster than ever now. Oh, interesting. You can change the timing based on the battery size. Interesting. Yeah, look at that. But, it's not really taking a charge. So, the high voltage spikes, I just putting a surface voltage on there. I'm gonna let it run a few minutes and see what happens. If it starts going up way too high a voltage, and I'll get nervous. But what I've done is I've connected I've turned on the jump starter part, which gives you a direct link into the battery, and I've put the leads, the alligator clips, onto the leads of the output of the generator, the motor, pulse motor output, but it's the rectified output from the diodes. Well, see what happens for a few minutes. It's just curious. If I can get any battery in here restored, then I'll have something to power this with, because right now all I've got is this little 6-volt guy. Oh, check this out, by the way. Whoa, Melanie, it scared me. Look at that. You can really slow it down. Really cool. Not doing much on charging though. Alright, well, we'll let that run a few minutes, see what'll happen.